Hello everyone. Let us start our discussion of physics paper of NEET 2025. So this is the first question. Here one question is given based on the Western Bridge and we have to calculate the current passing through the battery. So what we will do? We will first check the Western Bridge whether it is balanced or not. So you can see we have one Western Bridge here and it is connected to three more resistances as you can see, and one battery is also there. So we can visualize that this can be P, this is Q, this is R, this is S. So we can clearly see 3 divided by 1.5 is 2 and 5 divided by 2.5 is also 2. It means this Western bridge is balanced Western bridge. Therefore we can remove this middle terminal. And once we remove this middle terminal, we can calculate the equivalent resistance very easily. So if I redraw the circuit here, let's say this is 3, 1.5, 5, 2.5, and then 1 by 3 and 3 more resistances, 5.5, 1.5. So the equivalent resistance of this particular section will be 8 and 4, and the equivalent resistance will be 8 into 4, 8 plus 4, which is 12. Therefore this will be 8 by 3. Therefore equivalent resistance of whole circuit will be equal to 8 by 3 plus 1 by 3 plus 5.5 plus 1.5, and the total will be equal to, this is 3 and this much will be 7, 10. Since we have to calculate the current, so current will be equal to voltage divided by equivalent resistance. So this will be 5 divided by 10, which is equal to 0.5. So option 3 is the answer. All right. So in this question, we have one electromagnetic wave whose electric field is given here, and we have to identify the magnetic field. Well, we know that in case of electromagnetic waves, the electric field's direction and magnetic field direction along with the direction of the propagation all must be mutually perpendicular to each other. All must be mutually perpendicular to each other. Therefore, here in this equation we can see that the direction of propagation is along the x direction and electric field is along the z direction. Therefore, the magnetic field's direction must be along y direction, right? Again, we know that the magnetic field's value can be calculated like this. Ratio of electric field divided by magnetic field is equal to speed of light. Therefore, the peak value of the electric field is 60 here, and speed of light is 3 into 10 power 8. So this will be 20 into 10 power minus 8 or 2 into 10 power minus 7. So this B should be along y direction. So which one satisfies our answer? Option 2. Option 2 is the answer. All right. Now, here we have one question from waves and sound. So what is given? We have one open organ pipe. The pipe which is both open at both ends, and its fundamental frequency is given to be F in air. Again, it is mentioned that if the same pipe is dipped vertically into water so that half of its length is immersed inside water, then what will be the fundamental frequency of the same pipe? Well, according to the first condition, this is the open organ pipe. Let's say its length is equal to L. What is the fundamental frequency of open organ pipe? If we can remember, it is equal to speed of sound divided by 2 times the length. Now, according to the question, the pipe is dipped into water. Okay. How much length remains outside? Half of the length. Now this particular pipe becomes a closed organ pipe, and closed organ pipe whose length is equal to small l, let's say small l. And from the theory, what is the fundamental frequency of closed organ pipe? It is equal to speed of sound divided by 4 times L. But what is L here? it is L by 2, which is equal to V 2L. But again, this is what? This is the fundamental frequency of the open organ pipe. Therefore, both the frequencies will be same. So option 3 is the answer. All right. Okay, so what is this question? This question is from the magnetism chapter. Let's understand what is the question. According to the question, we have one electron. This electron, whose charge is given, it is moving with certain speed and it enters into a magnetic field perpendicular in the perpendicular direction. And in that situation, we apply uniform electric field in such a way that electron's path remains same. It means electron doesn't deflect from its original path. In that situation, what will be the speed of the electron? Well, this is a well-known concept. So I hope everybody can remember this. This situation will occur only if electric field and magnetic field are perpendicular to each other, and electric field and magnetic field's ratio should be equal to speed of the particle, charged particle. Therefore, electric field should be perpendicular to magnetic field, and electric field's value should be V multiplied by magnetic field. So what is the velocity of charged particle? It is C divided by 100, and the magnetic field's value is 9 into 10 power minus 4. So this is 3 into 10 power 8, 100, 9 into 10 power minus 4. So this is 3 into 10 power 6 into 9 into 10 power minus 4. Therefore, it is 27 into 10 power 2. So E is perpendicular to B, and the magnitude is this one. So option 3 is the answer. All right. Again, we have one more question. It is from the optics. What is given? In certain camera, a combination of 4 similar convex thin lenses are arranged axially in contact with each other. Then power of the combination and total magnification in comparison to the power and magnification of each lenses will be that we have to find. Well, so according to the question, we have basically 4 lenses like this. All of them are placed coaxially to each other. It means their principal axes are same. Now, we know that power is something which is linearly added. Therefore, if the power of each lens is P, it will be simply added. P1 plus P2 plus P3 plus P4. So this will be like this. Now, what about the magnification? You see, if you can remember the derivation of compound microscope. In the derivation of compound microscope, what do we see? In the derivation of compound microscope, we see the magnification of the microscope is obtained by multiplying 2 magnification, right? One magnification is for one lens and one magnification for the other lens. So magnification is always multiplied. Therefore, if the magnification of each lens is m, therefore magnification will be multiplied. It will be m power 4. So answer will be option 4. All right. We have one more question from magnetism. What is given? A 2 ampere current is flowing through 2 different small circular copper coils whose radii are in the ratio 1.2. We have to calculate the ratio of the magnetic moments, right? So simple question. So what is magnetic moment? So magnetic moment of first one to the second one will be equal to electric current in both the coils are same, but the areas will be different. So what is the area? Since they are circular coils, the area will be pi r square, and the ratio of the radii of the coils is equal to 1.2. 1 is to 2, so this will be equal to 1 by 4. So answer will be 1 by 4. All right. So here we have one more question. What is given? From the current electricity, a constant voltage of 50 volt is supplied to this circuit, and the circuit has 3 resistances: 1 ohm, 3 ohm, 2 ohm and 4 ohm. And we have to calculate the current from C to D, right? We can solve this problem by applying KVL, but it will take little time. So we will try to arrange something. So what we will do, let's calculate through division of the current. And for that purpose, we need to know the total current first. So what we will do, we will just consider first, uh, we will first calculate the equivalent resistance of this circuit by considering this to be a point. Okay. So if we do so, it will be like this. This is, let's say, 1 ohm. This is 3 ohm. This is 2, 4. The equivalent resistance of this circuit will be, this will be 4, 1 into 3 by 4. So this is equal to 3 by 4. And this will be 8 divided by 6, right? So 3 by 4 plus 4 by 3. So it is 12. 9 plus 16. So this is 25 by 12. This is the equivalent resistance of this circuit, right? So what will be the electric current? The total electric current passing through the battery, will be as follows. It will be voltage divided by equivalent resistance. So voltage is equal to 50, and this is 25 to 12. So this is equal to 24, right? So it means a total of 24 amount of electric current is flowing, right? A total of 24 amount of electric current is flowing. It means from this side also 24 amount of current will come, right? And in between that it will be divided. In between them it will be divided. Now we know that the electric current is inversely proportional to the resistance, right? So when this electric current 24 and try to enter this junction, it will be divided into two different parts. So how it will be divided? See, here we have 1 ohm resistance, here we have 3 ohm resistance, and total current is 24, right? So if I divide the 24 into 4 parts, right, one part will be 8. So 3 part will be going in this direction, right? So 3 parts will be going in this direction. So 3 part and 1 part will be going along this direction. So here in this way, I'm sorry, 3 parts will be going along this direction, 1 part will go in this direction, because here the resistance is less, here the resistance is more. So here 16 ampere current will go, and along this direction 8 ampere current will go, right? Again, this side 24 amount of electric current should come out, right? Now if I divide this 24 into 3 different part, you see 2 is 1 unit, and here we have 2 units, right? So if I divide it into 3 parts, so what will happen? So if I divide it into 3 parts, so one part will contain 8, right? So this way, yes, one part will contain, I'm sorry, wait, I think, yeah, this is 4. So if I divide this 24 into 24 by 4, so this will be, one part will be 6, and therefore this side 6 amount of electric current will come out, and this side 18 amount of electric current will pass. Now this 24 amount of current should pass through, should come out from the junction, and therefore according to the resistance the current will be divided. So here we consider 1 2 unit, here we consider 2 units, right? So electric current here should be more. So if I divide this 24 into 2 parts, right? So here how many parts are there? Here 1 2, and here we have 2 ohm parts. Therefore in this particular junction, if 18 is there, right, I'm sorry, 16 is there, this way 18 will come, right? Okay, if I divide this 24 into 3 parts, right, 2 part will go this way, 8 plus 8 16, and 1 part will go this way, which is 18. Now let's observe. If we observe carefully, 18 amount of current is passing like this, but along this direction, only 16 is coming, so 2 is missing, right? So 2 amount of current should pass through CD, so answer should be 2. All right, let's look at this question. What we have, we have two gases A and B, which are filled at the same pressure. They are filled at the same pressure in two separate cylinders with movable pistons of radius Ra and Rb, and then they are given some amount of heat. Okay, they are given some amount of heat, equal amount of heat indeed, and they are under constant pressure, and both the pistons are displaced by 16 centimeter and 9 centimeter respectively, right? Now if the change in their internal energies are same, then what is the ratio of the radiuses? Okay, now let us proceed. See, according to the question, we have two cylinders, right? Let's say this is cylinder A and this is cylinder B, right? So for this, if I write down the first law of thermodynamics, so Q is equal to change of internal energy plus work done. So what is given? Everything is under constant pressure, equal amount of heat is given. So heat is given, which is same, and change of internal energy is also same, therefore work done will be also same, right? In both the pistons, heat and internal energies are same, it means work done will be same. So work done by first cylinder and work done by the second cylinder, both will be same. Again, one important point is mentioned, that the processes are carried out under constant pressure. Constant pressure means this is isobaric process, right? So work done will be this one, P multiplied by change of volume equal to P multiplied by change of volume in the second cylinder. So PP gets cancelled, right? Now what is change of volume? You see, if I look at the cylinders, let's say piston moves up by certain distance, okay? Then what is this change of volume? So change of volume will be, so area multiplied by distances square. So what is the distance? Distance moved, let's say d1 for the first cylinder, and for second cylinder, let's say d2 is the distance moved by the piston, right? Now if I write down the areas and cancel them, so ratio of the radius becomes equal to d2 divided by d1, d2 divided by d1. So this is equal to r1 by r2 equal to d2 is equal to 9 and d1 is 16, and then this is square root, right? So this will be equal to 3 divided by 4. So answer will be option 3. Okay, now what we have, again one type of common question. Let's read the question. We have container which has two chambers, two separate chambers having volume 2 liter and 3 liter respectively. They are separated by certain partition which is made of thermal insulator, and in both the chambers it is given that we have gases of 5 mole and 4 mole respectively, ideal gases, and in both the chambers pressures are as follows: 1 atm and 2 atm. Now as in the common situations we deal, the partition is removed, and once the partition is removed, the mixture will attain the a particular equilibrium pressure, and we have to calculate that equilibrium pressure. So first of all, though, before mixing, what happens, let's understand. Before mixing, P1 V1 equal to N1 R T1. This is for the first chamber, okay? And for the second chamber, let's say this is P2 V2 equal to N2 RT2, right? Now since the P multiplied by V represents the energy and it should remain constant, therefore even after mixing the energy should remain constant, right? So this PV should be equal to P1 V1 plus P2 V2, right? So what is this? This is N1 plus N2, right? This is the total number of moles for the gas, and then this is R multiplied by common temperature, right? And this is equal to N1 R T1 plus N2 R T2, right? So this is common temperature, and the common temperature will be N1 R T1 plus N2 R T2 divided by N1 plus N2 then R. Let us mark it as equation 1. Okay, and after that, now let us write down this equation that after mixing the mixed pressure and mixed volume, it is equal to total number of moles R multiplied by T. I have to calculate this particular P. So N divided by V R multiplied by T. So what is N? N is the total number of moles, which is N1 plus N2, and the volume will be V1 plus V2. And what is R? What is T? T, as we have calculated from here. By the way, I can write down this. I may not, let's say I keep it as it is, that it is P1 P2 only, P1 V1 plus P2 V2. Let me keep it like this, P1 V1 plus P2 V2. Okay, so let me keep it as it is. So this is P1 V1 plus P2 V2, and then N1 plus N2 R. So once we do that, we see that these things gets cancelled, R gets cancelled. So what we observe, P is equal to P1 V1 plus P2 V2, and then V1 plus V2, right? Now let us put the values. What are the values given? So P1 is 1, and V1 is 2, P2 is 2, V3 is 3, and this is 2 plus 3, right? Okay, so this will be equal to 8 divided by 5. Okay, so this will be equal to 1.6, right? So answer is option 3. Thank you.